Hi everyone, welcome to Electronics with Professor Mughal. If I recall, this is the very first time I am doing a technology review and I'm super excited about that. This is a digital handheld oscilloscope with 2 channels, state-of-the-art oscilloscope, mid $500 range. And today we are going to explore the capabilities, features, and some of the specifications. We're going to talk about that. But before we begin, I want to talk about something. So what you see on the screen right now is a $25 a conventional digital multimeter that can measure resistance, capacitance, voltage, current, and there are more features these days in some of the fancy multimeters. But why do we need oscilloscope then? And what does oscilloscope does? Oscilloscope basically measure voltage. That's pretty much all it does. And why do you want to spend a few $1,000s to buy a desktop version of the oscilloscope or spend $500 to buy something of this nature? So the answer is oscilloscope does match. They sample data at a very high resolution over a period of time, and that's what makes oscilloscope extremely useful equipment in order to measure, test electrical signals over a period of time. Usually on the y-axis you got voltage and on the x-axis you got time. And this oscilloscope in particular can actually sample 1 giga samples per second. Can you believe that? If you are curious how to use an oscilloscope, you might want to watch this video because the user interface for this oscilloscope is very similar to that of the desktop version of an oscilloscope. So while we explore the features of this oscilloscope, I'm actually going to take you how to navigate through some of the options and features and use them in oscilloscope. So let's get started. Let's see what is inside. What inside is, you have the power adapter cable here. You also have a USB port to connect the oscilloscope with your PC. It comes in a very nice packaging with the Siglent, that's the name of the company, SHS810. That's the model number that you see over here. It's not too heavy. It weighs around 1.5 kg actually. You have multimeter pins here, 2 pair of probes. Okay, that's the BNC cable and that's the ground and that's the probe itself. Okay, here's a trigger to amplify the signal right here. So there are 2 of those. There's one more. Probably gonna need just one of them for now. Also, what was inside this bag is this adapter cable, and I'm gonna show you what we use it for. Actually, we're going to calibrate this thing, so we would need that. It takes roughly about 3 to 5 seconds for it to turn it on. Now, the very first thing that you will need to do here is actually, if you have not installed the battery yet, you might want to do that. At the back of the oscilloscope, there are 2 screws right. You need to remove those screws and then take this lid off and insert the battery. There's 2 ways you can actually power this. You can either use this cable right here, or you can just charge the batteries and then power it on. Right now I've already charged it for nearly 3 hours. So this is actually the model number right here. It has a bandwidth of 100 megahertz, can sample data 1 giga samples per second. Let's look at the front panel right here. You have these control keys over here. Here's the menu right here for the oscilloscope. Here's the auto button, run, stop, cursor, and measure. Very similar to that in the desktop version. You have channel 1 and channel 2 here. You also have the vertical position right here, these buttons right here. For horizontal position, you got the time scale right here. This is the voltage. Jackets for voltmeter, common, current. This is 10 and this scope basically has 3 features. When you turn the scope on, by default it is gonna be an oscilloscope mode, but you can actually change it to meter. And then as a recorder, believe it or not, this can actually record waveforms for 18 hours. Yes, it has an internal memory of 4 GB. On the side that's the power adapter port. Here's the USB port to connect it to import the data. And then you also have this adapter right here to calibrate the device and also to print the current waveform. What I'm gonna do here in front of you is I'm actually gonna calibrate this thing. So this adapter, I'm gonna insert it in there. One is the compensation probe right here, and then the other one is the ground. So I'm gonna take the probe and I'm going to use, say, channel 1. It also, by the way, has a stand. Use the stand if you like, but I'm not gonna do it because I got the overhead camera. So you'll see a square wave on the screen. I can position that. So the vertical position, if you're interested in looking at here, I'm only interested in looking at say a couple of complete cycles. So I am going to just click on auto here. When you do that, notice here it's gonna tell you the peak to peak voltage here is 3.12. Frequency is about 1 kilohertz here. You have the logo of Siglent, then you have which mode you are in. That's a triggered mode. The other mode could be auto, scan and stop. Using this button you can scan, stop it. Here is the waveform that you are looking at. This S is for right now. If you want to, you can save the current waveform that you see on the screen by connecting it with this this USB cable that came with it. If I want to say click on cursor and measure, click on acquire. Here are a couple of our options right here: peak detect, average, sampling. So this is channel 1, right? So I need to switch to channel 1. DC coupling, bandwidth limit here if you want to turn it on or off, volts per division. I will go to channel 1 right now. Channel 2 is not connected. I'm only using channel 1. So channel 1 has a peak to peak value. By the way, it has a rise time of around 3.5 nanoseconds. The screen size is 5.7 inches. It's a TFT screen with a resolution of 300 by 324 pixels. Decent enough. Okay, in case if your square wave is not perfectly squared, the edges are curved, looks like mine looks okay, there's a screw right here that you can on the Pro, see if I can show you here, this screw right here, if you can use this screw to adjust the shape of the waveform. Okay, and like I said, this unit operates using a rechargeable battery but can also take 110 to 240 volt AC. It operates at a 50 to 60 hertz frequency. Here's a trigger mode. Again, this is the slope. It's got edge, pulse. You can select your source switch between channel 1 and channel 2. Go to menus, go to setups. Here are the waveform picture, CSV, different options that you have over here. If you go to display here, you can switch between, you got two options, one with a white background, you got another with the black. I usually prefer white. Change the grid. Right now I got this, but if you want to switch it to this, that should also work. For channel 1, rise time is around 2.6 microseconds. V minimum is 0. Period is obviously frequency is 1 kilohertz. You can switch to channel 1, and I want to see peak to peak voltage. And now it changes to 3.08, and that's according to the manual. That's what it says. When you plug this adapter, it is supposed to give you a square waveform with a peak to peak value of 3.12 volts. So this is the oscilloscope mode of this handheld digital oscilloscope, and it's awesome. I'm gonna take you to the meter now. Let's look at the interface first. It'll tell you how the connections need to be made with the Pro. The good thing, which I really like, they also come with these alligator clips. Okay, if you want to use those, which is sometimes very useful, you can do that, or you can use this pin. Right now it is set to DC voltage mode. You can change it to AC voltage, diode, continuity capacitor, DC current, AC current. I'm going to measure DC volt. It tells you to put this red one over here, and then the black one goes here, which is the common, also labeled on the scope. This scale at the bottom that you see gives you the range, so it can, right now it's on auto set, but right now it says 0 to 600 millivolt. Obviously that is going positive terminal here and then negative terminal over here. So this is 4.954 volt, and that's what we were expecting, 5 volt, because I got 5 volts here. Maybe we can do a resistor. Okay, now it's set to resistor mode. I don't know what is exactly the value of this resistor, but let's find out. Go here and then go here. Looks like this is a 1 kilo ohm, actually 98.8 kilo ohm resistor. Okay, this is probably 100k. Actually, I'm gonna choose auto here. Hopefully it will adjust. So that's a roughly 100 kilo ohm resistor right there. Let's move on to the third mode, which is a recorder. Okay, and the good thing about recorder, you can actually use the recorder with the scope or with the multimeter as well. And I'm saying, and you got these three options right here: scope, trend plot, scope recorder. And like I mentioned earlier at the beginning, you can actually record waveforms over 18 hours on a single complete charge. It has a built-in 4 GB memory. I'm gonna choose meter trend plot. This is all happening real time. I am going to, this is actually gonna take 10 samples per second. Recorder, meter. Notice here the voltage is like floating at this point, but hopefully when I connect it over here, it should jump to 4.952 volts, roughly 5 volts. See, it jumped real time. And say if I remove the terminals, like the multimeter pins, it should go back to 0, and it falls right away when I do that. Extremely delicate device, and it's a great tool for someone who does testing or measurements on faulty devices and does a lot of traveling. This manual is very nicely written. This is what I was saying. If your waveform is like curvy like this, mine was like this, correct? But if yours is like curvy on the edges or the bottom or the top, then you need to use that screw and then rotate it such that you get a perfect square wave. We saw something similar on the scope when we were doing it. Who would need something as fancy as this? Probably not you. Well, the reason I got it was because I had to travel from one place to another, and sometimes I wish I have an oscilloscope so I can provide students with a quick feedback. I can do some electrical testing on some of the electrical signals or test different components on a circuit, and this is like really handy for me. I also did not want to buy something that's heavy, bulky, and fatty, but this is pretty slim. It's actually, the height of it is twice that of my iPhone 7, and it's probably 3 times as thick as the iPhone 7. Okay, so it's not too bad, but it does magic. It has a very high resolution, rise time of 3.5 nanosecond, and the good thing about it, it's got the meter also, and also it takes measurement over a period of time, and I can import that data into my PC, and that is great. That is great. This is what I wanted. So if you like it, give me a feedback, because I got more equipments that I have bought recently, and I can do some review on those too, and I hope you will enjoy. Thank you for watching, and if you haven't already, please subscribe to the channel. Thank you for watching. Bye.